Right, so today we are still on balancing chemical equations, and we're going to look at a bit more complex equation, chemical equation today. All right, and that is a chemical equation you're seeing here on the board before us. So this chemical equation on the board is a chemical equation between, we have C2H6 plus O2 giving us a product CO2 plus H2O. This chemical equation is a chemical equation illustrating the combustion of alkenes. So the alkene that we are seeing before here is ethane, and this is oxygen. Of course, combustion denotes reactions that involves oxygen burning. All right. Generally, for an organic compound, the product of combustion reactions gives you carbon dioxide and water. So how can we balance such a chemical equation? For an alkenes, of course, we know the product is carbon dioxide and water. The first thing to do is that we are going to balance carbon. We're going to balance carbon. All right. Now, before we continue, listen to this statement. I repeat myself. Listen to this statement. The way we're going to balance this chemical equation is not in a very usual way. All right. Because I am going to use this root to get to the general formula for balancing combustion reaction of alkenes. Ethane as an example. So I will use this to come up with the general formula. Alright, so you need to follow this because this is a very interesting journey. Alright, so the first we're going to balance carbon. Alright, so you can see here that carbon has two atoms. Alright. And carbon here has just one atom, one time. So what am I going to add here that will make carbon to be balanced? That is going to be 2. Yes, that's going to be 2. All right. We have balanced carbon. The next thing is, let us balance hydrogen. Hydrogen here, you can see there are 6 atoms of hydrogen. The number of moles of carbon here of ethane here is just 1. It's just 1. Okay, let me do this. Ethane, oxygen, carbon 4 oxide, water. Yes, that would help some persons watching the video. All right, so hydrogen 6. What am I going to put here that will make hydrogen to be balanced? Please look at this. Of course, we can simply say 3. That's very correct because 3 times 2 will give me 6. But I don't want to directly put 3 there. All right. This is 6. How did I get that 3? Okay. 6 divided by something. Look up. 6 divided by something, 6 divided by something is going to give me that 3. Of course, that thing is 2. 6 divided by 2 will give me 3. So that is how I got that 3. Yes. Or better still, 2 times what? 2 times what? Will give me 6. 2 times what? Will give me 6. 2 times x will give me 6. Alright? Divide both sides by 2. Divide both sides by 2. 2 cancels 2. 2 times what will give me 6. So x is equals to 6 divided by 2. Of course, we know that it is 3. But because of the general formula I want to prove, I don't want to put 3 there. Alright. So I prefer using here 6 all over 2. 6 all over 2. I believe that is understood. So we are balanced hydrogen. We are balanced hydrogen. The next thing here to balance is oxygen. The next to balance is oxygen. How are we going to balance oxygen? Now, if I rewrite this chemical equation, you would see that this will be C2H6 for oxygen. What is going to be here? This will give me to CO2 plus 6 over 2 H 6 over 2 H2O. Now, if you look closely, you discover that what is going to be here? What am I going to put here? Now, check the oxygen in the right hand side. You will see that these two covers carbon and oxygen. For oxygen, 2 times 2 will give me 4. So we have 4 atoms of oxygen on this side. And then for oxygen here, this 6 over 2, we have 6 over 2. All right. So you can see here that the oxygen we have is 4 plus 6 all over 2. Now, to find what is here, let's say this is P. The number of moles of oxygen here is P. Let's say it's P. This P times 2 should give you the moles, the sum of the moles, the sum of the atoms, moles of atoms of oxygen in the right hand side. All right. So watch this. So this will be P times 2 to give you the sum. That will be 4 plus 6 all over 2, which is the same as saying 2P equals to 4 plus 6 over 2. So to find P, I'm going to divide both sides by 2, divide all through by 2. So P becomes 4 over 2 plus 6 over 2 all over 2. You can see that this becomes 4 over 2, 2 goes here 1, 2 goes here 2. This becomes 2 plus 6 over 2 divided by 2 is something as 6 over 2 times divided by 2. We change it to times from the mathematics. That will be 1 all over 2. All right. So you know that what that becomes. So moving forward, you agree with me that P is given as 2 plus 6 all over 4, and going back to the chemical equation which we are supposed to balance, that means that to make this chemical equation balance, this is what should be in this place. So this becomes C2H6 plus 2 plus 6 all over 4 O2. This is 2CO2 plus 6 all over 2 H2O. All right. There is something very interesting I want you to notice here. All right. Remember, in my last video, I said we are not permitted to leave fractions as your moles, number of moles in the balanced chemical equation. You must break it up and simplify it. But just before we do that, look at this. What if this, the number of atoms of carbon was X, and the number of atoms of hydrogen was Y? Look at this critically. You discover that the general chemical equation for an alkene all right, it applies to alkenes too, and probably alkynes, all right, because alkynes, they just have two atoms. They are just made up of a carbon atom and an hydrogen atom. Carbon atom and an hydrogen atom. So this will be CXHY plus. Have you noticed that this is 2 and this is 6? So we can say that this is X plus Y all over 4. Have you seen how interesting this is looking now? Have you seen how this is going? This becomes, all right. Have you noticed this? That this is this 2. So we are coming up with a general formula now. So this is X CO2. XCO2. Have you noticed that this is 6 over 2? And this our 6 is Y. So this is plus Y all over 2 moles of water. So we have successfully derived the general equation to illustrate the combustion reaction of an alkene. This is ethane in this case. That TXHY gives you X plus Y over 4, giving you XCO2 plus Y over 2 H2O. This is the general formula for a balanced chemical equation. You can memorize this formula, but if you can't memorize this formula, you can go all the way, balance carbon, balance hydrogen, and then lastly, balance oxygen. But remember, we were not done with this chemical equation. We were not done. Let's be done with it. All right, so from here, this chemical equation, all right, the balanced chemical equation becomes C2H6 plus, simplifying this, you simplify this 2 plus 6 over 4, you know you're going to have 14 all over 4. 14 all over 4. All right. If you have 14 over 4, that's going to give you 7 over 2. Let me just do something for the sake of some persons. So, looking at this, finding the LCM of 1 and 4. LCM is 4. 4 divided by 1, that gives you 4 times 2, that gives you 8. 4 divided by 4, that gives you 1 times 6, that gives you 6. So this gives you 14 all over 4. Can you see that? That gives you 14 over 4. 2 goes here, 2, and 2 goes here, 7. So that gives you 7 all over 2. So coming down here, this is 7. From here, this is 7 all over 2, O2. This is 2CO2. Of course, we can simplify this. We can have our 3 now. We can have our 3 now. That gives you 3. All right. So this is 3H2O. 3H2O. All right. So at this point, we're almost done, but we are still having a fraction. All right. So we can't represent this. We can't leave it like this. All right. So we have to take the LCM. The mole here is 1 over 1. The denominator here is 1. Denominator here is 2. Denominator here is 1. Denominator here is 1. So the LCM of 1, 2, 1, and 1 is 2. So we're going to multiply all through by the LCM. I'll multiply this by 2. This will give me 2C2H6. That's 2 moles of ethane. 2 times, of course, these 2 will cancel these 2. So what we left here will be 7 moles of oxygen. Giving me, I'll multiply this by 2. This will give me 4 moles of carbon dioxide, and I multiply this by 2, this will give me plus 6 moles of water. Looking at that closely, we have been able to get a balanced chemical equation, all right, deriving the general formula and simplifying the equation to the very last point. All right. Moving forward, I'm going to show you the simultaneous equation method of balancing the same chemical equation. It could be very helpful when you meet complex chemical, a complex chemical equation. All right. Meanwhile, you can go about the same chemical equation in the steps which I have just showed you, but just in case, you can try the simultaneous equation method. So that's what I want to go through, and we are going to have the same results. We are going to have the same results, so that any method that it's easier to you, you can get yourself through it. So in the simultaneous equation method, I said that to balance the chemical equation, you add number of moles, and that are going to be variables A, B, C, and D. So in the last video we only talked about C, but in this video we're having D. All right. So in my next video, we are going to see a chemical equation that will give us to E and even F. All right. So stay tuned. All right. Looking at this, you can see that in the overall chemical equation, we have just one carbon, hydrogen, and oxygen. Those are the only 3 elements in the overall chemical equation. What you have in the product are the elements in the reactant, though forming different substances, but the elements are generally the same. So carbon, we tag at C, hydrogen, I tag it H, and oxygen, I tag it O. All right, let's move. Let's form our equations. So for carbon, this is 2 times A, that's 2A. Did I say any other carbon here? No. So I move. This is 1 times C, 1C, which is C. 2A is equal to C. Any other carbon atom? No other carbon atom. For hydrogen, this is 6A. Any other hydrogen atom? No other hydrogen atom. My arrow equals to 2 times D, that is 2D, oxygen. 2B equals to any other oxygen atom? Yes? No, in the reactant, but in the product, yes. So that is to C, giving me 1 times D, that's 1D, which is D. This is equation 1, this is equation 2, and this is equation 3. It is very important that while you forming this equation based on the element present in the overall chemical equation, that you are very careful that the chemical equations are correct. Because if you miss any step, if you make any mistake in forming the chemical equations, you will get it all wrong. All right. So it is important that this is checked, done very well. All right. Now we've gotten the 3 chemical equations. Remember what we do. Set A to be 0, not 0 to be 1. Set A as 1. So that's where we begin. If we set A as 1, so from equation 1, you can see that 2A is equals to C. That means that 2 into 1 equals to C. That means that 2 is equals to C. That also means that C is equals to 2. So I've gotten C as 2. All right. Now we've gotten C as 2. All right. A is 1. C is 2. Which other equation would be easier for us to substitute A or C or the both of them? All right. So I move to equation 2, I can see A. If I substitute A here, I will find D. So equation 2 is easier to work with. So substitute A equals to 1 in equation 2. This becomes equation 2 is 6A equals to 2B, so this will be 6 into 1 equals to 2D. Equals to 2D. You can see here that 6 equals to 2D, and of course, if you divide both sides by 2, you see that D is equals to 3. So A is equals to 1, C is equals to 2, and D is equals to 3. So we just have equation 3 left. And equation 3 said that O was 2B equals to 2C plus D. Yes. O is equals to, O gives me, that's for oxygen, 2B equals to 2C plus D. This was equation 3. Yeah. So in this equation, you can see that we know what C is, we know what D is, we just have to find B. So how are we going to find B? Let's substitute 2 into 2 plus, this is 3. So this is 2B equals to 4 plus 3. So this is 2B equals to 7. Divide both sides by 2. Alright, so this is B equals to 7 or over 2. So we can add here that B is 7 all over 2. B is 7 all over 2. Alright, so remember what we had was C2H6 plus O2 giving us CO2 plus H2O. And we said this was A, and our A is 1. This was B, and our B is 7 all over 2. This was C, and our C is 2. This was D, and our D is 3. A is 1, B is 7 over 2, C is 2, and D is 3. Alright, so you are following me, you will discover that this is the same thing we had before we eliminated the fractions, the denominators, which is the fraction. So you can see that the LCM is 1, LCM of 1, 2, this is 1, and 3 is 2. So we're going to multiply all 2 by the LCM, which is 2. So this is 2C2H6 times 2 times 2. 2 cancels. So this is 7O2. And this is times 2. This is 4CO2. And this times 2, this is 6 H2O. This is 6 H2O. So we've gotten a balanced chemical equation, and this is the same result we had when we used the general formula: balancing hydrogen, balancing carbon, balancing hydrogen, and balancing oxygen. Thank you. The next example we're going to do is going to be a complex example. And we are not going to use the trial and error method. We're going to strictly stay with the simultaneous equation method. See you in my next video. Alright, so you can like, you can subscribe, and you can hit the notification bell so that you will be notified whenever I release new videos. Don't forget, learn with master. All right, so you can share this on all your social media handles, and see you in my next class.